Very good evening, students. Hope all of you are doing fine. Welcome back to our new session. So today we are going to deal with the geometrical optics or ray optics. Okay, some of the advanced level questions. Okay, hope all of you are ready. Yeah, here we go. So starting with the first question. So we'll be taking the questions which are involving both mirrors, okay, reflection of the light, concave mirror, convex mirrors, and combinations of the mirrors. And also we'll be dealing with the problems which are involving the refraction also, both from plane surfaces and spherical surfaces, okay. And also one of the very important topic in this, again, in the prisms also. So all the different models we have planned in this particular session. Hope it will be useful for you, okay. So we'll start. First one, the image of an object approaching a convex mirror of radius of curvature 20 meters along its optical axis is observed to move from 25 by 3 meters to 50 by 7 meters in 30 seconds. What is the speed of the object in kilometers per hour? Okay. So actually the object is moving in front of the your convex mirror. It is moving in front of the convex mirror, right? So assuming this is a convex mirror, radius of curvature 20, so focal length 10 meters, okay. So the image, suppose whenever you are having a real object which is moving, definitely you are going to get a virtual image first of all, right? And the virtual image which is moving from 25 by 3 meters to 50 by 7 meters, right? So somewhere here earlier first image 25 by 3 8 point something and 50 by 7 7 point something, let's say, right? So the image is moving from here to here. So definitely the object maybe initially it may be here, finally it may be here. It is moving, assuming that object is moving with a constant velocity towards the mirror, right? Now first image distance I have given, first one 25 by 3. You can find the object distance by using the mirror formula, okay. So 1 by u1, so opposite side, so object is kept here, so minus u1 plus 1 by b 25 by 3 is equal to 1 by f, and focal length is positive, right? So here you will be getting 1 by minus 1 by u1 is equal to 1 by 10 minus 3 by 25, right? So just calculate the value of u1. How much you will be getting? By 50, that means u1 is exactly 50. The value of u1 is 50, okay, 50 meters. Similarly, in the same way, we are finding out the value of u2 also, right? So this was a u1 and this is u2, right? So for which the image distance is actually 50 by 7. Again use the mirror formula, right? So 1 by u1, now it is u2, so minus u2 because object left of the mirror, plus v2 because it's positive right side, v2 50 by 7 is equal to 1 by f, focal length is again 10, right? So minus 1 by u2 is equal to 1 by 10 minus 7 by 50, right? 5 minus 51, so minus 2 by 50, okay. So minus 2 by 50 minus 1 by 25 minus 1 by u2 is equal, so u2 is how much? 25. That means our object is exactly moving from, earlier you got 50, now it is 25. So it was moved from 50 to 25 means, so completely how much distance that it has moved? 25. Okay. So then they are asking, and that too is the time you are taking as 30 seconds only, right? So this is in meters. So you can, in 30 seconds, time is in 30 seconds. So overall you are getting 25 meters in 30 seconds. Okay. So what is the speed? So you'll be getting, so earlier it was in at 50, now it is 25. So how much exactly it has moved? 25 meters it has moved in a time 30 seconds, because image is also moving in 30 seconds, right? So by time 30, this so and so meter per So that you can convert it into kilometers per hour also, right? So that is a kilometers per hour you will be getting. So maybe like 18 by 5, so 25 by 30. How do you convert? 18 by upon 5. So 5 is 3. So it's nothing but 3 kilometers per hour. Okay. So clear? Okay, right. So that is the first question what we have got. So it is actually it's a virtual image only. In the convex mirror, what is going to form is a virtual image which is moving towards the mirror. So object is also actually moving towards the mirror only with a constant speed. So they have given the image positions. In that way you are able to make. Okay, so we'll proceed to the next question. All right. Okay, some concept here, like to make it. See, generally our questions are whenever the small objects are moving in front of the mirrors, right? So two very important useful formulas what we'll be having, that is velocity of the image. Okay, when it is in generally it is given in mm per second, like that. Suppose you are having a mirror like this and this is a small object which is moving. It can be moving like this with a small speed, or it can be moving like this, okay, along y-axis or along x-axis or even along z-axis also. So one thing, whenever it is moving along x-axis, that is along the principal axis, then the speeds of the image, how it works out. So speed of the image along the, I can say this is a longitudinal. When it comes to the longitudinal directions, speed of the image always equal to minus of v by u whole square times speed of object. Something like magnification whole square times speed of object. Okay. Whereas when it comes to the transverse direction, here again speed of image will be equal to the, so just simply it is equal to minus of v by u times speed of object. Okay. So some questions will be like a small insect is there which is having a velocity of some I cap, J cap, K cap, right, mm per second. So something like, I'll frame a one simple question here. So you have a concave mirror, some focal length, you take some 30 centimeters. Okay. You have a image, object which is at some 30 centimeters. So 30 centimeters means definitely in between f and 2f, right? And velocity of the object, let us say something like 2i cap plus 3j cap plus 4k cap mm per second, and given that this is x-axis and this is y-axis, right? So this is the z-axis. So clearly it shows that y direction and z direction are transverse direction and x direction is longitudinal, correct? Now that time, if this is the velocity of the object, what will be the velocity of the image? So find velocity of the image they are asking, right? So how to take about the velocity of the image? So first we'll take the position of the image, right? So here it is a focal length is 20, object distance is 30. If you calculate 1 by u plus 1 by v is equal to 1 by f, generally whenever the object is exactly between f and 2f, f and c, exactly in between, the image distance you are going to get double of the object distance. So in that way I'll get the image somewhere here, which is 60. Okay, and what is the magnification? And it is a definitely a real image you are going to get. So magnification will be -2, right? Now, so this is a longitudinal direction. These two are transverse direction. In transverse direction, m times. Longitudinal direction, m square times. Okay. So in the transverse direction, suppose if it is going with 3, definitely it will go like this with 6 m times. M is 2. And opposite direction. And in the, so that means here you will be getting -6 j cap. And even k is also a transverse direction. 4k, if it is going like this, object image will be going into the plane with 8 times. So -8k. okay, because see this, in the transverse direction minus of m times, correct? So minus of v by u, or simply m times you can put. So minus indicating that since it's a real image, whenever object is moving up, image will move down. Object is moving positive k, image will move negative k, right? And object is moving along like this with 2 towards the focus, image will move away, right? So that is why here also you will get minus and m square. So m is already 2, square means 4, 4 into 2, 8. This will be the speed of the image, minus 8I cap, minus 6J cap, minus 8K cap, okay, right. So these are the type of questions which generally we come across when you talk about the speeds, can a little of vectors, using of vectors in front of the mirrors, okay, right. So we'll proceed to the next question here. So this ball is dropped from a height of 20 meters above the surface of water in a lake, and the refractive index of water is 4.3. Okay, I think it's 4/3. That's a correction. 4/3. A fish inside the lake in the line of fall of the ball is looking at the ball, and at an instant when the ball is 12.8 meters above the water surface, fish sees the speed of the ball as. According to the fish, what will be the speed of the ball? Okay. So here you can consider one lake like this, and here is a fish is looking at the ball. Actually, ball was dropped from a height of 20 meters, and when it is ball is at 12.8 meter above the water surface, this is 12.8 meters above the water surface ball is. So that means it has already fallen for 20 minus 12.2, 7.2. Okay. So just find out its velocity of the ball. Velocity of the ball you find out. So once you know the velocity of the ball, accordingly you can find the what is the velocity of the ball as according to the fish, as observed by the fish. That is a question for us, right? So let us find velocity of the ball. So since it is falling from rest, you can use root of 2gh. So 2 into g10, h is 7.2. Okay. So here it will be 72 into 144. So under root 12 meter per second. That is the velocity of the ball. Now according to the fish, what is the velocity of the ball is what they are asking. So what you do, just you take this distance, and here fish is at rest only, right? So take this distance as some x1, this distance as x2. Now first we have to consider what is the distance of the ball according to the fish. Okay. So distance of the ball according to the fish is this distance. For the fish, this distance is same as x2 only, and this distance whatever is x1 is there, according to the fish it appears like nu times x1, right or not? Because fish is in the denser medium, object is in the rarer medium. So this distance whatever it takes, so that is appearing as nu times x1. This is the total distance of the ball according to fish. So once again, so this is x2 and this is nu times of x1, okay, according to the fish, because it is in the rarer medium and observer is in the denser medium, right? Now if you differentiate dx by dt, rate of change of the distance, that is only the speed, okay, dx2 by dt plus nu times dx1 by dt. And here fish is at rest, so that is why dx2 by dt will be 0. In some other cases, fish also may be moving up, so that time dx2 by dt you have to take accordingly that particular speed also. Otherwise, now here it is anyway at rest, right? So no need to consider dx by 2 by dt, it is 0, right? Now coming to the dx by dt, so this is what you are finding out. Dx by dt is equal to nu times, so what is the value of nu? 4/3 times dx1 by dt is nothing but speed of this, which is already we have got it as 12. This comes out to be 16 meter per second. Okay. So the speed of the ball according to the fish is nothing but 16 meter per second. So that will be the answer. Now here some more modifications to this question which you can make it by adding speed of the fish also. That correction you have to make it here. Then also it can be taken like suppose this completely is in a container. This totally will be in a container, and you make some hole to the container so that water level is dropping down. Okay. So when the water level is dropping down, this distance will increase or decrease accordingly. You have to check it, right? So dx1 by dt, so this level will drop with some speed and this speed. So x1 may increase or decrease provided this speed, if it is greater than this speed, then value of x1 will increase, and this speed is less compared to this, then x1 will decrease. Suppose assuming that for example here you got 12 here, and let us say this speed is, let us say 8. Okay. Now x1 is not decreasing at the rate of 12. The value of x1 is nothing but distance between the object and the water surface. So it is decreasing at the rate of 4. 12 minus 8, 4. So that time you have to put here as 4. And then x2, suppose here it is moving up, let us say. Then the x2 value is also decreasing at the rate of, suppose this is 6 given. Then the value of x2 is decreasing at the rate of 8 plus 6, 14 it is decreasing. So dx2 by dt you have to write, because it is decreasing, you have to write dx2 by dt minus 14. And dx1 by dt, x1 is also decreasing at the rate of 4. So dx1 by dt you have to write minus 4. That addition also you can make it, correct? So like that you can frame multiple number of questions of this particular model. Okay, right. So this is our question number 2, second question for today. All right, so we'll go to the next one. Okay. This is a previously appeared JEE advanced question, right? A monochromatic light is traveling in a medium of refractive index n is equal to 1.6. So here it was traveling in a medium of n is equal to 1.6. It enters a stack of glass layers. There are so many glass layers like this. Entering a stack of glass layers from the bottom side at an angle of 30 degrees. So here it is entering at an angle of 30 degrees. This is 30. Alright. Next. The interface of the glass layers. So these are all the parallel glass layers. Okay. Interfaces of the glass layers are all parallel to each other. They are all parallel to each other. Now, and the refractive indices of different glass layers are monotonically decreasing, like refractive index of the mth slab is n minus m into delta n, where nm is the refractive index of the mth slab. Okay, you are talking about refractive index. So by looking at this, it definitely feels that as you are going up and above, the refractive indices are actually decreasing. Okay, and delta n is 0.1, right? The ray is refracted out parallel to the interface between m minus 1th and mth slab. So m minus 1, this is m minus 1th slab, this is mth slab. Here it is coming out like this. That means here exactly whenever it is entering from m minus 1 to n, right? So whenever it is entering into m, so it is having angle of refraction as 90 degrees. Okay, so this will become the critical angle between this layer and this layer, because it is always going from denser to rarer only. So it is bending away from the normals. Finally, between these two layers, it is coming out of like this. So that means it is having this is a critical angle, so that it will have a 90 degrees there, right? Okay. So n of m is equal to n minus m into delta n, means n of m is equal to n minus n is what? 1.6 minus m into what is delta n? Delta n already given 0.1. So this one we are writing like this, substituting the value of n and substituting the value of delta n, right? Okay. See, whenever it is the parallel slabs, how to approach to this problem? Whenever it is a parallel slabs, you can use directly Snell's law at this point to this point. Means you can use the Snell's law directly from this layer, which is 1.6 to directly mth slab directly, because all are parallel only slabs, right? So let us apply the Snell's law here to directly here. So here what is the n value? N into sin 30 is equal to, here what is the refractive index of mth slab? It is let us say nu. Okay, just we think that it is a new value. All right. So nu into, okay, what is the angle it is making with in this particular medium? 90 degrees. So sin 90, which is 1. Okay, right. And new value you will be getting as exactly n by 2. Okay. So sin 30 is this one. So you are talking about which slab then? Refractive index exactly 90 degrees. So new value. So n by 2, what you are taking? So n is what? 1.6, so 0.8. So 0.8 means exactly which slab you are talking about, 0.8. So here now bring back here this one. So Nm is, this is the refractive index of the mth slab, which is 0.8 is equal to 1.6 minus m into 0.1. So what is the value of m then? Right. So m into 0.1 is 0.8. So m is equal to 0.8 by 0.1. So it will be 8th slab. So definitely this will come out to be the 8th slab. So m is equal to 8. Right. So that means between 7th and 8th slab, it will undergo exactly that critical angle will be there. So that is why angle of refraction will be exactly 90 degrees, grazing it will come like this. Okay, and clearly they are asking the value of m only, so that is why m value is 8 will be the answer. Okay, so just check it. Hope it is clear to all the students. Right, so here we are taking a continuously decreasing refractive index. Sometimes it can be given that it is a variable refractive index also. So that sort of a question also we can try to make it. Okay, one of that we'll try to make it. See, you have a completely layer like this. All right. So with y, refractive index is changing. Some function they may give you, right? And here it is entering maybe like this. Or this can be a denser and it's going towards rarer mediums. Or sometimes this can be rarer and it's going to higher, denser mediums. Okay. Assuming that this is from air, it enters at an angle theta, and as you are going up, refractive index is increasing, let us say. Okay. As y increases, nu also increases. So definitely when it is increasing, it is bending towards the normals. So you'll get something curve like this. Every time it is bending towards the normals. Okay. Now when you take a particular strip like this, whenever you are considering one strip like this, which is at a distance of y, and this is x. Okay, this is the value of x and this is y. Right. So just check this, in this particular slab, whose thickness is some dy. Right. So can I get this like a something like a triangle here? I'll just magnify it. So this is a normal. Right. In this medium, it is making an angle. So with the normal, this is a ray which is refracted into this medium. it is making an angle some. Okay, so this is given, assume that theta 1 and this is theta 2. Yeah, this is theta 2, right? So you take this as dx and this will be d pi, correct? Now you can here also, they are asking you to find this equation of this curve, right? They'll give you a nu as a function of y. Let us say nu is equal to function of y. Refractive index is a function of y, and they're asking us to find what is the equation of this particular curve. Okay, so how to do it? So here also I can apply a Snell's law directly between this medium air and directly this layer. Okay, here you can have refractive index of air is 1 into sine of theta 1, where theta 1 will be given, is equal to, here refractive index is nu into sine of theta 2. So nu will be a function of y, correct or not? So here you will have some function of y, and sine theta 2, from this triangle you can get the sine theta 2 value, because sine theta 2 will be opposite side dx by hypotenuse under root of dx whole square plus dy whole square. That is equal to 1 into sine theta 1. Assume suppose theta 1 is some 30 degrees they have given. So sine theta 1 nicely you will get 1 by 2. And here you are getting a function of y. So this forms a differential equation. And in this differential equation you can separate out the variables like dy along with y one side and dx other side, and then try to integrate by taking the conditions like at x equals 0, y is also 0, and try to integrate. You will get the equation for y with respect to x. Okay, so that is also can be a very good question, right or not? So you have all that you have to do is you have to solve this particular differential equation. All right. So you can bring this one here and squaring on both sides. Here you will get some function of y, that also you have to square, right? So how the type of function they are giving you, accordingly you are trying to solve it. Okay, right. Next one. So please look at this question. So 1 or 2 minutes I will give you the time. Just look at this question and try to understand this question. First of all, a planar structure of length L and width W is made of two different optical media of refractive indices 1.5 and 1.44. As shown in the figure. If L is very much greater than W, ray entering from end AB will emerge from end CD only if the total internal reflection condition is met inside. So because it's going from a denser to rarer medium, so total internal reflection chance is there. So for L is equal to 9.6 meters, if the incident angle theta is varied, the maximum time taken by ray to exit the plane CD. So maximum time. So they are asking about the maximum time. So just understand this question. So you can vary the value of theta here. You can vary the value of theta. Just think that this is an axis. Okay, this is the axis. So maximum time. See, there is a chance that it is going from, this is 1.5 and this is 1.44. So definitely it is going from a denser. See here, once it has entered into this, from air only it is entering. So here it is undergoing total internal reflection, means this should be the critical angle, greater than the critical angle. So the thing is, if it is very much greater than the critical angle, very much greater than the critical angle, then it will have a total internal reflection like this, like this, like this, like this. Correct or not? But they are asking maximum time. Maximum time is more number of reflections it has to take place. More number of reflections when it has to take place means this, whatever this angle is there, no? This angle. See, worst case is the critical angle. Just slightly, if it is greater than the critical angle, then it will have a reflection. But if you take more than critical angle, very much greater than the critical angle, then it will be going like this, like this, like this. So with less time it will come out. More time it has to come out, means more chances. Okay, that doesn't mean that if you take very less angle, it won't have a total internal reflection, it will have a refraction. That is a different. So what you do is you take this angle should be such a way that almost critical angle or just slightly greater than the critical angle if you take. So nicely you have a reflection, 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 reflection. So that means more distance it may travel, more number of reflections. It will get a chance to travel a more distance. Then it will take a more time. Okay, hope that is clear. So that is the reason we are taking this angle is almost equal to the critical angle, even slightly greater than. Okay, so more or less it is a critical angle only. So first let us find what is the critical angle between this medium and this medium. So what is the critical angle there? Theta c, sine of theta c is equal to refractive index of rarer by denser 1.44 by 1.5. Critical angle, right? Okay, so that is, now let me draw the same thing here. We'll go like this. Let us assume the critical angle over here, like this. This is the critical angle. So take this as A, this is B, and this is C. This is also critical angle. Right. And in this sine of theta c, which is that one. So in this triangle ABC, what is sine of theta c? Sine of theta c, is it not AC by AB? And sine of theta c is AC by AB. Means actually the distance traveled is AB. AB is the distance what it is traveling. And after that it will travel like this, like this, like this, like this. So even like this, yeah, I forgot. Okay, it can be traveling like this. So another medium, yes. So this will be again, it will be going inside this. So likewise, it is coming out. Done. And it will come out of the CD, right? Internal reflection. So because this is also 1.44, right? Okay. How to calculate? So finally, we have to get the length of this plus this plus this plus this plus this. That length you have to get. So if you get this total length by speed with which it is moving inside this medium, will definitely give you the time taken, right? So how do we get this length? We know one relation, sine of theta c is equal to AC by AB. So what I will do is, see, likewise this triangle here, one more triangle, here one more triangle, like this, every time it's having a triangle, right? So this one is there. So for AB, AC is there. For this one will be there. For this one will be there, right? Likewise, let us say this is 1, this is 2, this is 3, 4, 5, 6, 7, like that, some n number. So I'll multiply this and divide this with n. Okay, some n means I'm taking like this. Some n number is, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8, like that n times I'm taking, right? So n times of AB. Okay, this one, and n times of AC. N times of AC means, so AC is this one, then next to this one. For this one you will get this projection, 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 for this one you will get this. Likewise, if you take all projections, total n times of AC is nothing but here to your length, which is L only. And the value of L is how much? 9.6. So this value will be n times of AC is nothing but 9.6 L is 9.6 by n times of AB is nothing but this distance plus this distance plus this one plus this one, this one, this one, this one. Total distance what it has traveled. That is equal to sine of theta c. Already sine of theta c is 1.44 by 1.5. So what is the total distance that it is going to travel is nothing but so total distance. So 9.6 into 1.5 by 1.44. Okay. So this value comes out to be 0.28. Okay, in 10 minutes. The total distance what it has traveled inside this is 10 meters completely. So it has traveled a distance of 10 meters, right? And how much time it is going to take to travel at 10 meters? So the time they are asking. So that time easily you can find out the distance by speed. Speed in which medium? In the medium which is having a refractive index of 1.5. Okay. So how do you calculate the speed in the medium which is having a refractive index of 1.5 is speed in vacuum by 1.5. So that multiplied with the speed is less there. So how much? 0.5. This is I think 5 into 10 power minus 8. Okay. To exit the plane, so they are giving something like 10 power minus 9 maximum timer. So how much you get? 50 into 10 power minus 9. Check the calculations. So 10 meters is actually you are getting, and divided by speed in that particular medium of 1.5 is 3 into 10 power 8 divided by 1.5. Okay. So in they're asking time taken is t into 10 power minus 9 seconds. So what is the value of that? So t into 10 power minus 9 means here clearly you are getting 50 into 10 power minus 9 seconds. Okay. So that is the answer, right? So hope you have understood this question also. Right. So we'll look at the next question now. So it's something like it's a concept is based on the total internal reflection only. Completely the critical angle. Right. Next. Okay. So here there is a simple combination of concave mirror is also there and a convex lens. So this is a concave mirror, this is a convex lens. Refractive index of the convex lens is 1.5. So this refractive index is 1.5. Okay. And each are separated by distance 50 centimeters, right? Okay. Each focal length is 10 centimeters. This focal length is also 10. Actually, this focal length is also 10. And when it is kept in air, and this refractive index is 1.5. Right. Now, object is placed at a distance of 15 centimeters. Here is the object what you are placing at a distance of 15 centimeters from the mirror. Its erect image formed by this combination. Erect image formed by this combination has a magnification of m1. Okay. First combination means first let us say the ray will go like this. Combination means first mirror and then lens you take. Suppose if you take first only lens, after that you will get an image which cannot be formed again by the mirror, correct? So first you have to consider the ray is going like this, reflection, and then it is going passing through the lens. Clear? Right. And after forming a image, this combination will forming an image, first mirror then lens, right? It will get a magnification of m1. Okay, that is a question. Now, when the setup is kept in a medium of refractive index 7/6, this total setup, if you keep it in a medium of refractive index 7/6, then magnification becomes m2. Why the magnification is changing when the total setup is kept in another medium of refractive index 7/6? So that time, why it is changing? Because actually the refractive focal length of the lens will not only depend on the refractive index of the medium of the lens, but also on the surrounding medium also, correct? So that is why definitely this focal length of the lens will change when it is you are putting in some other medium, it will change. So when the focal length of the lens is changing, definitely magnification will change. So that magnification we are calling it as M2. So what is the magnitude of M2 by M1, that ratio they are asking, right? So first case 1, very simple. What you will do? First, concave mirror, object 15 centimeters. Already I told you it's like 15 is exactly the midpoint of F and C for the mirror, correct? So you will get the image which is double of this, right? Because focal length is double of this, means so beyond C you will get the first image like this. So here to here it will be 30. Mirror formula. First image, object distance 15 from the mirror, image is here, so first image 30, and the remaining distance you will be getting as 20, and this 20 is such that 2f is 20. The final image will be definitely here same 2f, because when the object is kept at 2f, image is also at 2f, this also will get 20, right? So that means here to here anyway magnification is 1 only, and here to here for the mirror the magnification is 30 by 15, 2, and for the lens it is because 20 and 20, so magnification is 1. So total magnification will be only magnification of the mirror, which is 2. So that means your M1 is 2. That's all. What about M2? M2 means you are keeping the complete lens in another medium whose refractive index is 7 by 6. Let us try to find out the focal length. So how do you find the focal length for that? First, for air, what is the focal length when it is in air? 10. So 1 by 10 focal length in air is equal to, so 1.5 by 1 minus 1 into 1 by R1 minus 1 by R2. They did not give R1 or R2. Keep it like that. Next you want the new focal length f dash, which is equal to, now it's again it is made up of 1.5 only, that is you can take it as 1.5, by which medium you are keeping, that is 7 by 6 minus 1 into same bracket 1 by R1 minus 1 by R2. So you can divide these two, okay, f dash by 10 is equal to, this is 3 by 2 minus 1, so this value will be 1 by 2, right? And this is actually 3 by 2 by 7 by 6 will be by 2 by 7 by 6, 2 3 is 9 by 7 minus 1, so 2 by 7. So this value will be 2 by 7, and 1 by 2 by 2 by 7 will be 7 by 4, 7 by 4, and this bracket and this bracket anyway will get cancelled. So f dash is equal to 70 by 4, 35 by 2 is the answer. I mean focal length, new focal length. Now we are talking about the new focal length of the lens, which is how much? 35 by 2. So try to calculate that. Okay, once you are getting the new focal length, see, even though if it is a new focal length, but focal length of the mirror anyway it will not change. So when you take the object here, first image will be like this only, object distance again you will get 20, but only thing is focal length will be 35 by 2. Now let us calculate the image distance by using the lens formula. 1 by V minus 1 by U minus 20 is equal to 1 by F. F is what? 35 by 2, 35.2, right? So 1 by V will become 2 by 35 minus 1 by 20. So just check it. So 140 to 4 to 8, 7, 1 by 140. So V will be 140. Second time the image will become 140. Okay. Now here the magnifications are already first time it is 2 times magnified. Second time object distance is 20, image distance is 140. So what is the magnification because of a lens 140 by 20, which is 7, right? That is the second time it has magnified by 7 times. First time already it has magnified by 2 times. So total how much it has magnified? 7 into 2, 14 times it has magnified. So that is why the value of M2 is 14. Now simply M2 by M1, 14 by 2, the answer is 7. Okay. Just check it once. So simple, we try to find out when this separate medium you have kept, we try to find out the focal length, new focal length, which you are getting as 35 by 2. And we later on for the same object distance 20 for the lens, because focal length of the mirror is not going to change because of some medium whatever is kept. Okay, so this is 20, so you will get the new image distance which is 140. All right. Okay. Right. So second time you are getting in the second case because of a lens you are getting 140 by 27 times, and because of a mirror 30 by 15 2 times. So total magnification will be 2 into 7 14 times, right? So that is why you are getting M2 as 14, M1 is already 2, so that is why M2 by M1 7, right? Done. So we'll move on to the next question. Yes. Okay. So look at this question. Please read this question carefully. It's a question is based on the prism. The monochromatic beam of light is incident at 60 degrees on one face of an equilateral prism of refractive index n and emerges from the opposite face making an angle of theta, which is a function of n with a normal. See figure. For the value of n is root 3, the value of theta is 60 degrees. So suppose if you consider this is n is root 3, then you are getting the theta is 60. But if it's a different value, you will get a different value here also. Of course, this is fixed, I is fixed. But definitely angle of emergence will definitely depend on the value of n, right? As this is changing, this will also change. So how they are changing? For a particular case, when root 3 is there, then it is 60, that's confirmed. Then how it is changing? D theta by dn at that instant. At that instant, if how theta is changing with respect to n. So d theta by dn, that they are asking. Okay. So first, because they are asking d theta with respect to n, so try to get the relation between theta and n. So theta as a function of n only, you try to get the relation, right? So we have to use the Snell's law there. So let us take this is some R1 and this is some R2, and it is the equilateral prism. So R1 plus R2 is 60 degrees here, right? First you apply Snell's law at this particular phase, which is this is air. So 1 into sine 60 root 3 by 2 is equal to, right? It is n into sine of R1. And second equation, try to apply the Snell's law from here to here also, right? So here this is R2, this is some theta you take. So n into 1 into sine theta is equal to n into sine of R2, right? So 1 into sine theta is equal to n into sine of R2. This is only at a particular case when n is root 3, then theta is 60. But some other value of n, theta will be some other value. So that's what you are asking, how theta is depending on n. Okay. So just put it in here. This is a theta, right? So clear Snell's law, and already you know the relation between R1 and R2. Finally, the target is getting the value of theta in terms of n. That's it, right? How do you make? Sin theta is there. You divide? No. So what I do? Sin theta is equal to n into sin of R2. R2 you can write in terms of 60 minus R1, right? That is sin theta. So your sin theta and R1 also, you know what is sin R1? Yes. Sin R1 is how much? Root 3 by 2n, no? Sin R1 is root 3 by 2n. Now what we do? Sin theta is equal to n into, so this you can write as sin A cos B, okay, minus cos A sin B, right? So theta function of n, but R1 is there, and that also try to write in terms of n only, because you know sin of R1 is this R1, sin of R1 is root 3 upon 2n. So this value will be 4n square minus 3. Correct? So the same thing you substitute here. Sin theta is equal to n times root 3 by 2 into cos of R1 is what? 4n square minus 3 by 2n. Okay, minus half into sin of R1 is what? Root 3 by 2n. Right? Okay. So finally this n is getting cancelled here, here and here. So you will be getting sin theta is equal to, okay, so that n is anyway getting cancelled. So root 3 by 4, okay, times 4n square minus 3 minus of 1 by root 3 by 4. So root 3 by 4, n will is getting cancelled anyway, right? So this is the value of sin theta, which is a function of n only. N is coming here, but this n is cancelled with this. Now what we will do? But they are asking d theta by dn, right? So don't try to take theta is equal to again sin inverse of all that, and then you try to differentiate d theta by dn. But instead here only you can differentiate like d of sin theta is what? D of sin theta, is it not cos theta into d theta? Cos theta into d theta. And d of this, so you can write it as, actually this is nothing but root 3 n square minus some 3 root 3 by 4 anyway constant, minus root 3 by 4 is all constant only. So if you differentiate d of all this, you will be getting 2 root 3, okay, root 3 into n square, root 3 as is n square differentiation 2n into dn, and d of all this constant is anyway 0 only. So clearly d theta by dn, they are asking d theta by dn is equal to 2 root 3 n by cos theta. So at a particular instant they have given, at which instant they are asking d theta by dn? At the instant when the value of n is already root 3 and theta is exactly you are getting 60 degrees. So substitute value of n is root 3. So root 3 root 3, 3 to 6 by theta is coming out to be, yeah, 60. So cos 60 1 by 2. Right. D theta by dn. So any calculations? Okay, all right. Okay, so I think went a little bit missed. This is root 3, root of we did not write. Okay, so cos of r, this is what you are supposed to write. Okay, just have the correction. So root 3 by 2 cos. So cos of r1 is root of 4n square by minus 3 by 2n. Okay, so that is a small correction what you have to take. So root 3 by 4 square root of this. Yes. Okay, so just let me correct this. Just we did not take this root. Okay, root is there. Not just try to simplify again. Cos theta into d theta is equal to root 3 by 4 into root of 4n square minus 3 is what? 1 by 2 root of 4n square minus 3 into d of 4n square, which is 8n. Okay, and dn. And d of this is anyway 0. Now you try to substitute. So d theta is there, dn is there, d theta by dn. Or here only substitute what is cos theta at a particular instant where theta is 60. So cos theta is 1 by 2. 1 by 2 into d theta is equal to root 3 by 4 to 8 cancel. Okay. Root 3 into this n is also root 3. dn is there by root of 4n square minus 3. So n is root 3, no? So root 3 whole square 3. 4 3 is 12. 12 minus 3 9. Root 9 is 3. So root 3 to 3 cancels. So d theta by dn equal to 2. Okay. So d theta by dn you are going to get exactly 2. Okay. So please make that correction. So here that root is missed. So if you would not take that, you are getting actually d theta by dn as 12. So but actually the answer is d theta by dn is 2. Okay. Now I hope it is clear. So it's overall what they are asking is clearly how theta is function of n. N is changing, theta also will change. At a particular instant, when one condition is given, like at a particular instant when n is root 3, theta is 60, at that instant, what is the variation of theta with n, right? Variation of theta with n at the instant when n is root 3 and theta is 60, right? So d theta by dn is 2. Okay, done. So we'll have the next question. So go through this question. Monochromatic light is incident from air on a refracting surface of a prism of angle 75 degrees and refractive index is root 3. The other refracting surface of the prism is coated by a thin film of material of refractive index n as shown in the figure. The light suffers total internal reflection at the coated prism surface for angle of incidence theta less than or equal to 60. Less than or equal to 60. If theta is greater than 60, it won't have total internal reflection. Then what is the value of n square? What do you think? So this is having a value of n. It is undergoing total internal reflection here. Theta is less than or equal to 60 degrees. Okay. So that means if theta is, suppose theta is exactly 60 degrees, then here it will bend towards the normal like this. And here it will have a total internal reflection, let us say. I mean exactly 60 degrees means it will have a grazing like this. Okay. If theta is less than 60, then theta is less than 60. This value, theta is decreased, this value increases. Sorry, this is decreased, theta decreases, this also decreases R1. R1 decreases, R2 will increase. R2 will increase, compulsory it will have a total internal reflection. Right? It all depends on this value of theta, correct or not? So once again, so exactly at 60, this is having a grazing critical, because that time R2 becomes exactly critical angle. Suppose if theta is less than 60, Okay, so less than 60, R1 also decreases, R2 will increase, so that means R2 will become more than critical angle, compulsory you will have total internal reflection. That is why they are clearly giving that theta less than or 60 only it will have total internal reflection, means 60 degrees is the exactly the critical angle, right? So between this medium and this medium, the critical angle is 60 degrees. Okay. So when the critical angle is 60 degrees, sorry, this is 60, sorry, this is 60, then this becomes the critical angle. Okay. So when theta is 60 degrees, R2 is becoming exactly the critical angle. Right or not? Find out that critical angle. First to find R1 and from that R2 you find out, you will get the critical angle, and that critical angle is nothing but refractive index of rarer medium by denser medium. You can take it. So how do you calculate this value of R2? So first you apply Snell's law between these two. Okay. 1 into sine 60 is equal to root 3 into sine of R1. R1 is 30. R1 is 30. So this is 75. So R2 will become 45. That means critical angle is 45 degrees, right? So critical angle is 45. Sine 45, 1 by root 2 is equal to refractive index of rarer by denser. Refractive index of rarer is n. Okay, and denser is root 3. Okay, so n is equal to root of 3 by 2. So root of 3 by 2, root of 1.5. So n square is 1.5. Okay, clear? Simple question only. So most of the time this will depend on this, confirm, because this will depend on this, ultimately this will depend on this, right or not? So most of the questions in the prism, we are trying to, by adjusting this value, okay, you are trying to make it whether it is having a total internal reflection or not, you are able to make by adjusting this particular value. Okay, right. So we'll move on to the next question. Yeah, look at this. So just go through once, all of you. Right. So for a prism of prism angle theta is 60 degrees. Prism angle theta is 60. Okay. So theta is 60 degrees. So the refractive indices of left half and the right half respectively N1 and N2. This is N1 and this is N2, two halves. So this is the prism angle 60, but this is left half and this is right half. Both of them are having N1 and N2, right? So the angle of incidence I is chosen such that the incident light rays will have a minimum deviation. So this I you are choosing in such a way that this angle of I you are choosing in such a way that it will have a minimum deviation if N1 and N2 both of them are equal to 1.5. You know very well that, see, whenever it is completely N1 and N2 both of them are equal to 1.5, right? This is 1.5 and it is a minimum deviation. The I is chosen for minimum deviation means definitely the refracted ray will become parallel to the base. Compulsory it will become parallel to the base, and these two angles are equal, okay, which is they are equal to, because sum of these two is 60. So compulsory you are choosing I in such a way that R1 and R2 So this is R and this is also R. So 2R is equal to 60. So definitely R will be 30. Means R and R2 both of them are equal to 30 degrees. Like that you are choosing. And it is going parallel. This is going parallel to the base. So this is exactly parallel to the base. Like that it is going. Okay. Right. Now that is when these two are having equal refractive index, right? Okay. But for the case of unequal refractive indices, suppose refractive indices are not equal, N1 and N2, both of them are not equal. N1 is N only, but N2 is a slightly varying N plus delta L, where delta L is very less, means N2 is a little bit higher than N1, right? That time the angle of emergence E is equal to I plus delta E, right? And which of the following statements is are correct for that? So here we take like this. First it was going normal like this, parallel to the base, right? So all that counts is here. Now what are the changes that you will be getting? This is definitely when these two are equal, right? So that time it is parallel to this and this 30 degrees. And even if these two are not equal, here it is a difference. So is it not going normal to this face? So when this ray is going normal to this face, definitely it will go like this normal only, right or not? So still if these two are not equal also, it will go same like this. And this angle is still 30 degrees. Okay. Now you take this is N2, this is N, this is N2, and you have to get this value which is I2. Provided, so how much is I2? We have to check. First in place of I we will check. Okay, earlier when N1 and N2 are equal, what is the value of I? So just apply the Snell's law. I'll take the next page for this. Okay, go to the question and some options are given. So what is the value of delta I in radians, greater than that, delta I proportional and all these things. Okay, step by step we'll try to see this. Okay, right. I'm taking the next page. Okay, so first we have to take the value of I also by applying Snell's law here and here, because R value you got it as already 30, because minimum deviation, right, R value is 30. So how to get the value for I? You can apply the Snell's law. So 1 into sin I nu is actually 1.5, that is 3 by 2 to sin R, sin 30, 1 by 2. So sin of I is equal to 3 by 4, right? When N1 and N2 are equal, this angle is such that sin I is 3 by 4. This angle also will be equal to I only, such that sin I is equal to 3 by 4, because when N1 and N2 are equal, but N1 and N2 are not equal. No, N2 is a little bit greater than N1, right? So how do you take for the value of N2 then? So you can apply Snell's law here and here. Okay, I'll apply Snell's law here and here. So N2 into sin 30, next page. N2 into sin 30. Okay, N2 into sin 30 is equal to 1 into sin of I2. 1 into sin of I2. Because N2 is different, so I2 is also different. When N2 is 1.5, definitely I2 will be equal to I1, which is sin I is nothing but something like 3 by 4. Okay. Now, what we want to do? There is a small change in N2, so there is a small change in I2 also. And I2 is given by something like I plus, what is that? I2 is nothing but emergence, yeah, E. I am taking I2, here it is E. I plus delta E, right? Okay. I2 is equal to I plus delta E. And N2 is nothing but N plus delta N, that's all. There is a small change in the value of N2. So that is why there is a small change in the value of I2 also, right? So simple. So what we do is just to differentiate on both sides. Sin 30 1 by 2 into d of N2. So d of N2 Sin 30 1 by 2 is equal to sin of I2 is what? So differentiation of sin of I2 cos of I2 into d of I2, right? So where you are changing at the instant when N2 and N1 both of them are equal to 1.5, okay, at the instant when N2 is equal to 1.5, then that time I2 you are getting exactly as I1, which is equal to sine inverse of 3 by 4, because I1 you got already sine inverse of 3 by 4. When N2 is 1.5, once again, so I1 and I2 both of them are equal to sine inverse of 3 by 4, right? So there is a change in I2. The change in I2 is there because of change in N2. So what is change in N2? Change in N2 is nothing but delta N, and change in I2 is nothing but I plus delta E. That's all. So this is your delta N by 2 is equal to cos of I2 into change in I2 is delta E. Change in the angle of emergence, delta E, small change because of small change in N. That's all. So from this you can find out. So here cos of I2, no, already sine of I2 or even is same as sine of I1 at that particular instant is 3 by 4. So take this triangle 3, 4, this is I, which is I1 or I2, both of them are same when N1 and N2 are equal to 1.5. So this comes out to be in minus 9. How much it is? Something like root 7. Okay. So cos of I2 is what? Root 7 by 4 to delta E equal to delta N by 2. So delta N is equal to root 7 by 2 times delta E. That's the relation between delta N and delta E. So delta N is equal to root 7 by 2 times delta E. So let us get back. So what you got? Delta N is equal to root 7 by 2 times delta E. So look at this and just try to check it. The value of delta E in radians is greater than that of delta N. So root 7 is around 2.6 around, okay, by 2. So 2.5 is 6.25. So 2.6, if you, even if take 2.6 by 2, 1.3. So delta N is roughly around 1.3 times the delta E. Now please check it, which is greater means delta N is only greater. So value of delta E is greater than delta N, wrong. Delta E is proportional to delta N, yes. Delta E is definitely proportional to delta N, correct. And delta E lies between 2 and 3 milliradians if delta N is 2.8 into 10 power minus 3. So just check if delta N is 2.8 into 10 power minus 3, 2.8 if you take, this is 1.3, so 2.8 means, I mean 2 point something, okay, yeah, milliradians, this will be correct. If you take delta N as 2.8 into 10 power minus 3, definitely delta E will be 2.8 by 1.3, which is 2 point something into 10 power minus 3, which is milliradians you will be getting, okay, right. And if delta E lies between 1 and 1.6, okay, what about delta N? So even if you take 1.6 here, 1.3 into 1.6, okay, so you will not get 2.8, right? Only this what you are going to get. So that is why these are the two options, option B and option C are correct for this particular question. Okay, right. So this is also a very good question. So previously appeared only JEE Advanced. What you got this question that we have solved, right? So we'll get back to the next question. Okay. A parallel beam of light is incident from air at an angle of alpha on the side PQ. Here it is alpha on the side PQ of a right angle triangular prism of refractive index n is equal to root 2. Light undergoes total internal reflection in the prism at the face PR. Here it is undergoing total internal reflection. when alpha has a minimum value of 45 degrees. So again, minimum value of 45 degrees here, what we got, then it is undergoing total internal reflection here, means like just grazing like this. Then what is the theta of the prism, angle of the prism they are saying. I am redrawing this. See here, this is the normal, and alpha has the minimum value of 45 degrees. So this is alpha with 45 degrees if you take, bending towards the normal, and here it will have a grazing, total internal reflection, right? The minimum angle. So because the problem is, if you increase this, okay, this will increase means this will decrease. This will decrease means it will have a refraction, right? So that is the lowest value is 45. Right. Okay. So angle theta. So how do you approach? So theta they are asking this n is equal to root 2. So this becomes a critical angle. So critical angle will be definitely sine inverse of 1 by root 2. So 45 degrees this is, right. So this is 45. This is also 45. And this is 45. This is 90. So try to check this angle there. By applying Snell's law here and here, 1 into sine 45 is equal to root 2 into sine r. So sine r is equal to 1 by 2. So that means r is 30. This is 30 degrees. Is already 90 degrees. So just consider the triangle A, B and C. Okay. So if you consider this triangle like this, already this angle is 45. This angle you want theta, and this angle is what? 90 plus 30. So it's 120. So 120 and 45, 165. So this will be 15 degrees is the answer. Check it. So what is the angle of prism they are saying, which is 15 degrees. Okay. So clearly that's minimum value of 45. Then it is undergoing total internal reflection, means and this is 45, this will become the critical angle. And critical angle is already calculated 1 by root 2, 45 degrees. Okay. Hope you have got it this question. Right. So we'll proceed for the next question. This is again a prism question only. You have a combination. An extended object is placed at a point O 10 centimeters in front of a convex lens L1 and a concave lens L2 is placed at 10 centimeter behind it as shown in the figure. The radius of curvature of all the curved surfaces are 20 only. All the curved surfaces radius of curvature is 20. So this is also 20, this is also 20, this is also 20, this is also 20. Right. And the refractive index of both the lenses is 1.5. So this take 1.5, 3 by 2. This is also 3 by 2. Total magnification of this lens system is. So you just a total magnification. So two refractions, first refraction from the convex lens and second refraction from the concave lens. So two refractions are taking place and you have to get the total magnification. First refraction you will get some magnification, second refraction you have to get some magnification, total magnification m1 into m2. So first find out the focal length. So first find out the focal length. You know very well that when 3 by 2 radius of curvature, two equal radius of curvature, 20 and 20 and this is 3 by 2 kept in air, compulsory your focal length will be same as radius of curvature. Same as radius of curvature. This focal length will be minus 20. Apply the lens maker formula, you will get that. Okay. Now, first time object distance 10, focal length 20. So definitely you will be getting a virtual image only, right? So that virtual image, so you can calculate that. So lens formula 1 by V minus 1 by U is equal to 1 by F. Okay. So V1 you have to calculate. Step I will take. So 1 by V1 minus 1 by U is what? Minus 10. 1 by F is 20 plus 20. So 1 by 20 minus 1 by 10. And so V1 will be actually minus 20 you will get. Check it. The first image will be somewhere here. First image is here. Because the rays, if you observe these rays, so first you will get the diverging rays and it will become less diverging. Diverging only, but less diverging, as if it is coming from here, as if they are coming from here. So for this concave lens, these rays are actually coming from here. Okay, so this will have a feeling that these rays are coming from here, as if an object is kept here, real object. So what is this distance now? So earlier this was here to here, already it was 20 you got. Okay, now this is 10 plus 20, so for this object distance should be 30. Okay, and first time magnification is what? Magnification 1. So object distance is 10, image distance is 20, so 2 you will get virtual image, so plus 2. Okay, next for the concave lens, object distance is considered to be 30, focal length 20. Okay, so what is the position of the image? Right. So say 1 by v minus 1 by u is equal to 1 by f. 1 by v2 minus 1 by u is what? Minus 30, so 1 by minus 20. By v2 will be equal to minus 1 by 30 minus 1 by 20. So come on. 30 on 60, so minus 2 minus 3 minus 5 by 60 minus 1 by 12. This is going to minus 12. It will be equal to 12. Yes. So magnification M2 will be V by U. V is 12, U is 30. So 2 by 5 magnification. So total magnification is M1 into M2. M1 is 2, M2 is 2 by 5. So total magnification 2 into 2 by 5. That is 4 by 5. Okay, so 4 by 5 we are getting as something like 0.8. Okay, so answer will be 0.8, right? So very simple combination. Okay, first image and second image you are able to make, and you are able to get the total magnification, right? Okay, so we'll go to the next question. Fine. So water with refractive index 4 by 3 in a tank is 18 centimeters deep. So water is 18 centimeters deep. This is 18 centimeters. Oil of refractive index 7 by 4 lies on the water. Make a convex surface of radius of curvature r is equal to 6. This r is 6. This radius is 6. Radius is 6. Okay. Consider oil to act as a thin lens. It's acting like a thin lens. An object S is placed 24 centimeters above the water surface. So this value we are taking as 24 and neglecting this thickness of the oil layer, right? But it is having radius of curvature. Okay. So the location of its image is x centimeter above the bottom of the tank. Okay. X centimeter above the bottom. See, first when the object is kept here, you will get spherical refraction from air to this one, and then from here to here you will get a plane refraction, and you are locating the final image. Correct or not? So that is the idea. So first we consider the spherical refraction. So spherical refraction, we are using the formula for spherical refraction, that is nu2 by v minus nu1 by u is equal to nu2 minus nu1 by r. Okay. So what is nu2? Ray of light is going from this medium to this medium. So nu2 is 7 by 4 on v1. We have to calculate minus nu1 is air 1 by u is a minus 24 is equal to nu2 minus nu1. So 7 by 4 minus 1 by r. Radius It is like this. So in the direction of light, so 6 1, right? So 7 by 4 V1 is equal to 3 by 4 6, 24, that is 1 by 8. Okay, so minus 1 by 24. So 7 by 4 V1 is equal to, this will be 2 by 24, 1 by 12. So what is V1? 21 you will be getting. So V1 is 21. So that means here I'll show you the ray diagrams. First it will have a diverging rays like this. They'll try to converge at 21. And actually this is a very thin layer, right? So this is a very thin layer. So they'll try to converge at 21. But when it's trying to converge at 21, again there is a medium change from 7 by 4 to 4 by 3. So it can be interpreted like this. So here it is 7 by 4 and here it is 4 by 3. Now the rays are trying to converge. Color this one, yeah. So the rays are trying to converge like this. As if they are coming from 7 by 4 to 4 by 3. They are trying to converge exactly at 21 here. But there is a change in medium from 7 by 4 to 4 by 3. Okay. Like denser to rarer. So they'll move away from the normal. So put the normals here and here. Instead of converging here, okay, they'll be bending away from the normal. So actually they'll bend like this, less. So the real distance will be 21, but this is the apparent distance you have to find, which is less. So how do you find 21 into theta? You will be getting the less value. So you take 4 by 3 by 7 by 4, right? So 21 into 16 by 21. So 21 cancels. Answer is 16. So from here it's actually 16, right? But they're asking from the bottom. So already this depth is 18. So from here you got 16, means the remaining will be 2. So the answer is 2 centimeter. That will be the answer. Okay. So this is a question which is completely based on the spherical refraction. Don't try to use any length formula here, because this side is different medium, this side is different medium. Don't try to use any plano convex length formula and all, right? So just take the spherical refraction formula and after plane refraction, go with the basics. Nicely you are going to get the answer, right? So okay, so that's all for today's discussion. Okay, so we'll stop the discussion here. So ray optics is also one more important chapter, okay, in which you will be getting a lot of questions and especially combinations of questions. So ray diagrams is very, very important here. Total internal reflection concept is very important. Prism with total internal reflection concept is important. Okay, just even if you go to the previous questions, whatever we have got in the recent JEE advanced questions, it will be a very good practice as far as geometrical optics is concerned. Okay, hope you do geometrical optics properly in the final exam. Okay, thank you very much. We'll meet for the next session. Thank you.